Hi everyone, I'm Saranya Sriram from the Azure Cosmos DB Product Program Management Team, and today we're going to talk about monitoring Azure Cosmos Database. Building applications and solutions on Cosmos Database is interesting, of course, easy, advantageous, developer friendly, and very rewarding. Many capabilities out of the box that the platform promises, such as global scale, very low latency, automatic failover options, multi master concurrent writes on availability, so on and so forth. However, a good product deployment is only half of your work done. To be able to monitor, analyze, optimize for various factors such as availability, performance of your app, cost, throughput are very, very critical. It is indeed pivotal for successful deployment and ongoing operations. Cosmos database collects various metrics and logs, both on the server side and on the client side. This video will show you an overview of these and where you can find more information. On right hand side of this chart, we see out of the box options. One, on the Azure Cosmos Database portal blade itself, where we do store metrics up to last 7 days. Also another Azure service, namely the Azure Monitor, which aggregates and monitors metrics logs across all Azure services and supports Cosmos DB for a richer end-to-end look. Here we have two options, the option 2 and option 3 with the Azure Monitor. One is out of the box to review various metrics, and secondly, you can write your own queries on the diagnostic log tables and activity tables to take a deeper look on monitoring logs. Finally, as developers, we surely want to access these metrics and logs as well from our client-side SDK. Cosmos DB exposes these via .NET, Java, Python, and JavaScript SDKs, and we do have access to all of these. So first, let's look at the Azure Cosmos DB portal for various charts and metrics that are available out of the box. For this, we've created a .NET console app that goes ahead and does a bunch of inserts into a Cosmos DB collection or container. Also spits on the console, as you see, the number of documents that's being inserted at number of writes per second and an average throughput RU that is being set. This will help us create a pattern for us to look at our metrics. The account that we have set up also has auto scale set up on it, and we will take a look at that. Here on the Azure Cosmos DB portal, going towards the metrics on the blade, we can go and take a look at the overview section. Select the database, the containers, and the time slot that we want to look at. We could do a custom time slot and go ahead and put in a custom time up to the last 7 days for us to go and directly look at these charts. So out of the box, we see average throughput per second, average request per second, the total data size, and the index size with those corresponding charts. Of course, we do know averages might not be the best of indicators, and we probably want to look at the max, the min, etc. Let's look at certain parameters. Most of our customers look at this throughput page, again for a similar data set of containers, and we can go and select again the custom time that we want to set up. Given that we have set up auto scale on our account, going into our data explorer for this collection scale settings, we see a maximum of 4,000 RUs has been set. Hence, the fluctuation is automatically scaled from a minimum of 10%, which is 400, all the way to 4,000. So you see at 400 is your min bar, and at 4,000, the maximum RU per second. Clearly, our inserts are definitely between that, the load that we're generating, and the RUs that are actually being charged and provisioned is somewhere between the max and the min. You will also notice that since we are well below the maximum provisioned throughput, we definitely don't have throttled or error issues related to throttling. And hence, this 429 error is quite empty or blank. The other charts that folks definitely use is about the number of requests in terms of the HTTP error codes and the HTTP codes that come out of it. So this is a good chart. Let's now turn into the partitioning strategy. Pretty pivotal for all troubleshooting scenarios. There are two things here for me to call out. One is the max consumed RUs per partition key range. In fact, this probably is not your best friend or best metric to look at. This really talks about the physical partition and the maximum consumed RU at one of those physical partitions. However, in Cosmos DB, essentially we all look at the logical partitions because you kind of set the shard key or the partition key for the logical partitions, and all the physical mappings are automatically handled by the system. A better metric to look at and for us to feel safe is really the normalized consumed throughput capacity. Essentially what this says is across all the physical partitions at any particular instant of time, it's going to go and say which is that physical partition which has the maximum RU that has been consumed, and it's going to make a percentage map of that. That is to kind of say at 3:27 p.m. on this chart here, 30% is the maximum consumed RU. That means one of those physical shards has using 30% of the provision throughput. A good benchmark to have this here is about 60 to 70 or 80% is pretty good. On the other hand, very closely related to this normalized consumed throughput is this heat map that you see. This heat map shows on a chart of color coded from green to red how is the throughput distributed across the actual physical shards. Essentially what this shows is that if it is green, means that your peak normalized throughput is actually not just hitting one single physical partition while all the other partitions are sitting idle. However, if you see red here, this essentially might indicate that all of your normalized throughput that is being said here is actually hitting only one of those partitions, which means we've provisioned throughput for the other partitions and we are not using those throughputs for the other partitions, and hence you're actually wasting and you're paying for something that you're not using. A good chart to look at. Outside of this, the metrics also gives us access to storage, which gives us the total data that is being stored and the index that is being stored as well. Cosmos DB guarantees financially backed SLAs, and those SLAs are also showcased in terms of availability. We see that the actual availability is pretty much 100%. The SLA is 99.49 SLA, and we are sticking onto the SLA. Latency is pretty cool to look at. Single millisecond read and write latency. So at the read level, we are getting about 1 millisecond, while on the write, which is the inserts that's this .NET app, which is actually doing right now, is about 4 to 5 milliseconds. Pretty cool. Similarly, SLA on the consistency is also mapped, since we are having a real replication from US to South Korea, kind of gives you the status or consistency of data within this window, right? So this gives the out of the chart box. Next, let's take a look at the Azure Monitor service and how that aggregates and supports Cosmos database. On our Azure portal, we could go open up a new Azure service, the Azure Monitor. And on the left hand side, on the blade metrics, go ahead and pick up a scope. Select my subscription, refine my scope into Azure Cosmos DB accounts, pick up a location in my case, and I know exactly the Azure Cosmos DB account that I would love to monitor and look at the metrics for. So in this case, we see under the metrics tab, we do have a lot of metrics available. including, say, some management control plane operations such as account created, deleted, etc. There's also the auto scale max throughput that got integrated. Let's just quickly take a look at that. Here, we select based on the max, and just as we saw that we have our account provision for 4K, the auto scale max throughput is 4. I could add another metric here. In this case, I'm assuming I want to take a comparison between a provision throughput and, for example, the maximum throughput, and I go ahead and take a look at this. We have options to change the window of time, and this data that we have is for until the last 30 days. So let's go take a look maybe at the last 1 hour, and we kind of see over the last 1 hour how our provision throughput has varied based on our load, because we are inserting documents and we're creating a artificial load compared to our main throughput. So this is one of the charts. We could add multiple new charts showcasing various other metrics. Let's go take at the server side retries just to see a server side latencies. Let's go for that. In this case, this kind of shows us what has been the server side latencies. I could go and say, let's add a splitting. I want to see all the server side latencies based on collection names. So in this case, I have a few collections. It's showing based on that. On operation types, various operations, query, update, read. Read versus query, the difference in Cosmos DB is read is more like a read doc. It directly goes and does point read, versus a query is more like goes via the index. So it looks at it as select something from something. So these are some out-of-the-box charts available. There are various charts. One last chart, maybe just to close this section, is to look at the total request, and in which case I could go and say these are my total requests available. I could filter this based on a particular collection. In our case, let's look at the benchmark collection and say this is my total request for the collection. I could also put in a filter to kind of say, hey, let me pick up all the status codes. In this case, I've not got any errors. So you see this is what we have. Or I could go and go based on various operation types to see this. In this case, obviously there are creates versus query and reads are very limited, since this solution is more like going and creating and inserting. Monitoring Azure Cosmos DB. The next option via the Azure Monitor logs. So next, let's move on from metrics to look at the Azure Monitor logs for Cosmos DB. Here's a quick distinction between what really is metrics and logs. As we just saw, metrics are more like point-in-time numerical values that describe some aspect or some part of what we are looking for. They are like standard sets of properties. They're collected at regular intervals and they are visible from the Metrics Explorer. Logs, on the other hand, are typically structured or unstructured, and they are events that occur in the system. They tend to have more rich query language access. In our case, we would use Azure Data Explorer's KQL to access them. And they have a unique set of properties depending on the type of the log. So types of logs and the classifications of log is interesting and critical. In our demo here, we are going to look in two types of these logs. One is called data plane request types for Cosmos DB, and the other is called the query runtime stats. Outside of this, we do have options to look at other kinds of log types. So to kind of give a quick recap as what kind of log types is possible, let's actually go back to our Cosmos DB blade. Here we have something called diagnostic settings. When we click that, and go ahead and add a new diagnostic setting, we have opportunities to send particular log types either to various sinks like a log analytics, storage account, or real-time tumbling window like the event hub. Essentially, normally customers do pick up the log types that they are interested in: data plane request, query runtime statistics, partition key statistics like how, and then RU consumption, control plane request, so on and so forth, to send to your log analytics. Once you send that, the data will stay there until you decide to purge them. In our case, in our demo, we've already configured log analytics, and we're sending all this data that we're creating from this collection on Cosmos DB here. Going back to the Azure Monitor on the log side, we have a couple of things to play around with. First and foremost, when we click on the logs, we do some out-of-box queries that we get access to, such as when I click on run in terms of the RU consumption, I could go ahead and say run here, and we would see that this is a data plane category, and we're trying to say here I want data from 24 hours. Let's go ahead and change that to a more realistic 1 hour window and rerun this query. It's going to go generate the RU consumption of every single request that has happened through our data plane request category 1 hour ago. So if you look at it, this is a syntax similar to SQL, but not really. But you can go take a look at Azure Data Explorer to kind of figure out how this works. The other point to talk about logs is that typically all data from pretty much many Azure services are logged into the log analytics in the Azure Monitor space. They tend to use ideally 2 tables. One's called Azure Diagnostics table and the other the Azure Activity table. So the Azure Diagnostic table, we look for a resource provider called Microsoft.DocumentDB to be able to get all the data or all the logs related to Cosmos DB. So in our case, for this example, let's go to our Cosmos DB account and let's actually run a query, right? So in this case, I'm executing a query, select star from the current collection, which is benchmark, and I'm able to get a bunch of data. I go to the query stats. I kind of see it's about 10.84 RU, and all of these query stats is another interesting area to take a look at the various monitoring metric stats here. So now going back to our Azure Monitor, we could run this for the last 1 hour. Essentially what we're trying to do is trying to go and read certain parameters from the category type query runtime statistics. So here we just saw this query that we ran. We can open this up and we will see that it seems to be select from something, gives all the parameters. Sounds kind of promising. Now let's run a little more other queries, such as let's limit that query into specific fields or properties that I want to run in. And in this case, I'm just picking ID, amount, and currency. I can go back to my logs. I could run this again and hopefully giving it a little bit of lead time for it to actually get the data and collect it here. We should see that query land up here as well. While we're waiting for this, what we can do at the next level is to go ahead and look at, for example, this activity ID for this particular query. I could go and run another diagnostic for another category, which is my data plane operations, to be able to go and take a look at the request charge and certain other parameters. In this case, I'm able to see that this query, a particular query, took a certain request charge and with this particular activity ID, and it's able to go and say, this is my client IP address. I could go and say, what's my IP? You would see my IP address is 219.74.6.157, which is essentially what the Custo query has traced as well, and then kind of guesses which is my user agent accessing this. When we open this up, we are able to also get a little more detail as to connection mode. Cosmos DB allows two sorts of connection modes. One is gateway assisted, another is direct mode to the backend storage engines. So it kind of says what are these that are the data plane operation parameters. At this point, let us continue to go here and refresh this to see if we did get the data that we were looking for. Yes, now this data has come back. So if I look at this, it essentially says select c.it, but then c.p1 and p2, it's parameter 1 and parameter 2, and this is pretty much what we did. So we could go back here and look for this activity ID. In fact, let's go ahead and just list all of the query parameters and see if we can pick up the latest one, which corresponds to this ID, and then we could see a similar value of the data items that come here. So we also have issues of bad request. For example, assuming I'm intentionally setting a bad request, I can go and take a look at those bad requests on my data plane as well. So opening that, you can see you can query based on the status code. And in this case, we've created a status code of 400. So you can go ahead and query on that particular status code. And when I run this, we can get the data that we just went ahead and got the status code. So this is a quick round of how we can use Azure Logs and using the Azure Diagnostics to go and take a look at. For all the various fields available in Cosmos DB that can be searched and queried, you have an easy lookup on the UI right here. Azure Activity gives you more granular activities, and that's also pretty helpful if you're trying to look for details, and you can actually correlate one table with another as well. The Azure Metrics is also pulled into the Custo Log Analytics, so you can actually query on the Azure Metrics table as well. Finally, we come to the client or programmatic access. Let's go back and take a look at the very beginning, the chart that we had brought up. Monitoring Azure Cosmos DB. Till now, we did see, looking on the right side of this picture, which is directly from the Azure Cosmos DB portal, using Azure Monitor, and then through metrics and logs. On the left side of the picture is really the end developer's access to Cosmos DB's metrics and logs. You can do that in two ways. One, using REST access, we can look at the response header that you see here. Let me just go back and show this to you really quickly. All of the client SDKs are deployed on GitHub, and you can take a look at that as well. From the documentation and the link on our PowerPoint deck, we will notice that the common Azure Cosmos DB's REST API response headers include a bunch of fields, which also include things around request charge, things around various quotas, so on and so forth. So this is hugely useful. Now coming over to the client-side SDK, just taking an example of .NET here for completion. In .NET, we have 3 versions of client-side .NET. We launched the V2 version, which was more stable and used by many customers, and that goes by the NuGet package name Microsoft.azure.document.client. The fundamental class, which is the document client.read document collection async class, returns a response for the resource called the resource response. Back here again, you have all the links on the deck to take a look at the document line.read document collection. And when we go down and kind of look at what it responds, it's a resource response. And when we go into that, pretty much a lot of properties that include the collection quota, the size, the usage. We also have collection-wise, we have database usage. So pretty much many resources, request charges are all included in this. From .NET version 2 to version 3, we went through some sort of an ideological change in the way we performed and organized our SDK. The NuGet package, of course, is microsoft.azure.cosmos, but what is interesting here is we have one common Cosmos diagnostic class. And this Cosmos diagnostic class pretty much can attach itself to various operations of various kinds of resources. For example, we could attach this, say, to create or get the list all the databases. We could attach that to reading this operation and then be able to spit up the diagnostics. We could attach that to listing all the containers and then spitting that. We could attach this to query definitions, such as in this case, I'm selecting all. I could attach it to that, and then I could display the diagnostic. So that is a fundamental way in which the V3 version has changed. The V4, which is still in works and is going to be out soon, where you also have options to, it's on GitHub, so it's all available. It's by the namespace azure.cosmos, and we'll see you on that piece soon. So with this, thank you very much for listening in and hope this video was useful.